This polynomial division worksheet is just like the ALEKS assignment you did yesterday, only more complicated. So look at number 1. We want to divide 4x to the 4th plus 4x to the 3rd plus x squared minus 10x minus 125. Divide that by 2x plus 5. Okay, so you can work this with me. You don't have a ton of room. I'm sorry. This division has 2 rows and an unknown number of columns. We put 2x plus 5 on the left, and then we stick in the first term from the numerator, 4x to the 4th. So what times 2x is 4x to the 4th? 2x to the 3rd. Does everybody understand that? We're essentially dividing 4x to the 4th by 2x, and we get 2x to the 3rd. Okay? And now we multiply 2x to the 3rd and 5, and we get 10x to the 3rd. Now we add a column. Do you remember what the next step is? These two need to add to be 4x to the 3rd. So minus 6x to the 3rd. Then we pull out a 2x, and we get minus 3x squared. Sorry, where did I mess up? So 2x times what is negative 6x to the 3rd? No. No, if you have 10x to the 3rds and you subtract 6x to the 3rd, then you end up with 4x to the 3rd. I didn't mess up. That's a first. All right, so we take this 6x to the 3rd and we divide it by 2x, and we end up with negative 3x squared. Negative 3x squared times 5 is negative 15x to the 3rd. Then we add a column. These two need to add to be, oh, sorry, I did mess up. Okay, that should be a squared. Thank you. So these two need to add to be this. I have negative 15. I need a positive 1. So we add 16 plus 16x squared. Now we divide that by 2x, and I get plus 8x, hopefully. And then 8x times 5 is 40x. These two need to add to be negative 10. How do I go from 40 to negative 10? Subtract 50x, good. And then we divide by 2x. Uh-oh, he's on his phone. Are they good looking? Oh. Do you have anything to say about that, Calvin? All right, so negative 50 or divided by 2x is negative 25x. Negative, oh, not x, just 25. Negative 25 times 5 is negative 125. And these two need to add to be negative 125. So there's no remainder. So this division happens evenly. Just like 36 divided by 9 is 4, with no remainder, this division had nothing left over. Everybody got the same number of Skittles, and there was nothing left over. No. So this is our answer. 2x to the 3rd minus 3x squared plus 8x minus 25. So something really interesting happens here. How do those two expressions differ? What is the difference between this graph and this graph? Well, it's sort of like saying, what's the difference between 36 over 9 and 4? Nothing really, except what happens when I plug in negative 2.5. What happens when I put negative 2.5 in there? The denominator becomes 0, right? When I plug in negative 2.5, the bottom becomes 0. So that gives me an undefined equation, which means I'm not allowed to plug in 2.5. So whatever this graph looks like, so this graph here looks like this, something like that, I don't know, right? The only difference between this expression and this expression, if I graphed it, is at negative 2.5, there's a gap. So it goes like this, there's a gap, and then it keeps going. We call that a hole in the graph. The only difference, oh, he's on his phone. Man, you like doing that. Both of you don't like your grades. Were they good looking? Yeah? Okay, then it's worth it. So the only difference between the original expression and the other expression is there is a hole in the original. So what happened when we did this division? We went in and we plugged the hole. And you're going to learn more about those graphs a little bit later on. All right? Okay, let's do number let's do number 4. So 4 says x to the third plus 27 over x plus 3. This has 2 rows and an unknown number of columns. I put in the x to the third. X to the third divided by x is x squared. And x squared times 3 is 3x squared. Okay? Now what? What do these two squares need to add to be? 27? 0. Why 0? There are no x squareds in my numerator. So this numerator is sort of like saying x to the third plus 0x squared plus 0x plus 27. And my second diagonal has to add up to be equivalent to the number of x squareds in the numerator, and there aren't any. This would be negative 3x squared. Does everybody get that? So we pull out an x and we get minus 3x. Negative 3x times 3 is negative 9x squared. Oh, not x squared, it's just x. I did it again. I'm sorry. How many x's do I need? Positive 9, because my numerator has no x's. So plus 9x, pull out an x, plus 9. 9 times 3 is 27. Does this have a remainder? No, it doesn't. All right, let's do number 8. Okay. All right, number 8. 3x to the 4th plus 4x squared minus 13x minus 4. And how many rows is this going to have? Look carefully. 3. What is the middle row? So the first row is my 3x squared, and my second row is 0x. Do you have to put a 0x in there? No. However, I'll show you what happens if you don't put that in. Maybe we should do number 7 first. Let's do 7. This one will make a little bit more sense. So 2x to the 4th plus 8x to the 3rd minus 5x squared minus 4x plus 2. So this one is going to have 3 rows, and that one's pretty obvious. X squared plus 4x minus 2. Okay, so we stick in 2x to the 4th. What happens when I divide that by x squared? I get 2x squared. Everybody okay there? 2x squared times 4x is 8x to the 3rd, and 2x squared times negative 2 is negative 4x squared. Everybody good? Okay. Add a column. These two need to add up to be 8. So how many more x to the 3rds do I need? 0. So 0x to the 3rd. What happens when I divide that by x squared? What is 0x to the 3rd divided by x squared? Not x, 0x, which we don't really need, right? But we're going to put it in there because it will help me fill out the rest of the table. 0x times 4x is 0x squared, and 0x times negative 2 is 0x. Does everybody follow? Am I going too fast? No? Okay. Add a column. Now, these 3 need to add to be negative 5. Minus x squared. So minus x squared. Okay. Pull out an x squared and I get negative 1. Negative 1 times 4x is negative 4x. And negative 1 times negative 2 is plus 2. Okay. Now, these 3 need to add up to be negative 4x. So how many more x's do I need? None. I already have negative 4. 0 minus 4 is negative 4, and that's what I wanted. So this is a remainder, and it's a 0. Okay. These 2 need to add up to be 2. And they do, so the remainder is 0. Okay, now put your pencils down for a second. What if my remainder was 3x minus 4? How would I write that remainder onto my answer? You write plus, it's always a plus. Even let's say this is a negative 3x. It's always a plus. And then you write negative 3x minus 4 divided by x squared plus 4x minus 2. Okay. Now, what is the difference between the original expression and this expression? And the answer is nothing. Because it had a remainder, the original is like the improper fraction, and the answer is like the mixed number, and their graphs are exactly the same. Now, it is possible that there is a hidden hole in there somewhere. So it is possible to have a remainder sometimes and still end up with a hole. But in this case, there wasn't one. Okay. All right, so let's go back to this one. Do you see now why we need 3 rows? Okay, so let's do the first column. We bring in 3x to the 4th. What is 3x to the 4th divided by 3x squared? X squared. This becomes 0x to the 3rd, and this becomes negative 2x squared. All right. Now we add a column. These need to add up to be 0x to the 3rd. Do you see how it's missing? There's no x to the 3rd there. So 0x to the 3rd, which makes this 0x, which makes this 0x squared and 0x. Okay. Those need to add up to be 4x squared. So I have a negative 2 and a 0. How do I get to 4x squared? Add 6x squared. Good. Pull out a 3x, and I get plus 2. So 0x and minus 4. Okay. These need to add up to be negative 13. So I need a negative 13x. And those need to add up to be minus 4, which it already is. So it's a 0. So how do I deal with that remainder? Plus negative 13x over 3x squared minus 2. Now, what do you notice about zeros in these tables? There are a lot of them. So when there is a 0 here, here, what does that do to the table? The whole row is 0, except maybe the remainder. It doesn't affect the remainder. What do you notice about a 0 here? The whole column is zeros. So if that's the case, why do I put that there? Well, the reason is, if we were to delete this row and then squish this table together, now my diagonals don't line up anymore. Right? So it is possible, but it's very, very difficult if you don't put the zeros in. So the reason we put them in is with a 0 row, then all of my diagonals line up and I won't make a mistake. Okay, look at number 9. Do you have any missing terms on either the top or the bottom? No. What about 10? You're missing an x to the 3rd and an x on top. And what about the bottom? You're missing an x on the bottom. So number 10 would have 3 rows. Okay. What about 12? Are you missing anything? Nope, they're all there. What about 11? A 4 and a 3 on top and a 1 on bottom. Does that make sense? All right. Question. So that's a really good question. Once you get here, you're going to have remainders. And the reason is, can I take a 3x squared out of a negative 13x? No, I've run out of x's. So as soon as this exponent is smaller than this exponent, then everything from there over is going to be a remainder. And there's really no way to do it. Like there's no way to pull out an x squared. So once you reach the constant, everything after that is a remainder. Good question. All right, get to work.